We know where 0.526 is going to be. It's going to be at the center of the curve, which is going to be somewhere right about here, right? Ish, somewhere. It have to be a little bit to the right, probably. Somewhere like here. And then if you go out, say, 2 standard deviations, you know you've trapped 95% of your data. Is this ringing a bell from 243? Good. Now the question I have for you is this. 95% of what data? Data in the population?
Sample.
Data in your sample. Damn! We're still stuck in the sample, aren't we? Everything you're looking at right here is your sample data. Well, poop. I don't want to be on the sample data. What do I want to be? I want to be in the population. So here's a recap from 243. I'm going to slide this over this way. So here's your sample. We're going to compare and contrast the population sampling distribution with the actual sample distribution right here. That's what this is here. Now, the population distribution, this is the weights in pounds. The sample average is 0.52, correct? 0.52. Where's the population average? Assuming we got a good random sample, which is arguable since it was me in Bend on a bike every Wednesday night at like 5:30. Arguable, it's not random. Let's pretend it is for sake of argument. Where's the population average going to be? Over here. 0.52, right around there, yeah? What guarantees us that? Do you remember? It's okay if you don't remember. Remember that?
They moved together on your move.
Oh, good! You're thinking more recently. Good for you, Elizabeth. Yes, they move together. On average, they move together. I was thinking the central limit theorem, but that's probably too long in the past to remember from last summer, last spring. They move together. Good. I'm glad I showed that spreadsheet earlier. Good, 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 good. What shape is the population's distribution? This is such a trick question, I feel bad even saying it. What shape is the population's distribution? It's a trick question because you can't know that, right? It's like, I don't know. You shouldn't know that. It could be skewed. It could be uniform for that matter. The sample distribution came in at a bell curve, but the central limit theorem pretty much guarantees that too, to some degree. But the sampling distribution of the average, now this is a different animal. This is a different animal. The sampling distribution of this average, if we drew all possible samples, will be a bell curve. It will be a bell curve. That central limit theorem guarantees us that. If you drew every possible sample of size 30 from the population of Del Taco half-pound bacon cheese burritos, and you graph those results on a curve, it will be a bell curve. Here's my next question. How tall and how wide? Will it be the same as that one? Will it be taller and skinnier? Will it be shorter and fatter?
Red.
We got to vote for red. What governs the change in the sampling distributions? This is going back. I'm picking that hippocampus part of your brain now. What governs the height, the skinniness of the sample distribution? Do you remember this? I'm going back to 243. I'm such a bastard right now. Brian?
Wouldn't it be the number of samples?
The number in your sample governs that, doesn't it?